Mechatronics Lab is developing an in-pipe leak detection sensor for small air and water pipes. The sensor and platform for air have already been constructed, but a platform needs to be made for water environments. The sensor functions through the use of a rubber skirt mounted to a gimbal mechanism, indicated here. The sensor is pulled down the middle of the pipe by a locomotive. When it passes a leak, the local negative pressure will suck the skirt against the wall. This rotates the gimbal slightly, causing one of an array of force-sensitive resistors to be depressed, sensing both leak severity and location. A previous version of the water locomotive had been attempted, and while it was capable in a free tank, it was unable to move through a water pipe. This stemmed from a weak motor, non-streamlined design, and clunky waterproofing method that were all accounted for in the latest drivetrain design. With an integrated waterproof external shell, it can be easily taken apart through the removal of 2 bolts along the parting line. These are attached to the front half through heat-set inserts. The locomotive is powered by a lithium polymer battery, controlled by a custom XB Arduino stack, and moved through a 12-volt Maxon motor attached directly to the propeller's shaft. An effective rotary shaft seal was developed for waterproofing concerns on the rear shaft, combining an oil reservoir, X-ring, and PTFE shaft seal. Preliminary tests showed that the assembly was quite waterproof and very powerful, but it suffered from severe stability issues. Since the sensor needs to remain precisely in the center of the pipe, this concern needed to be addressed in the next design of the locomotive. The new design incorporated stiffer springs and a custom preloading method to ensure leg stiffness, even with slight displacements, as well as rubber wheels to prevent rotation and oiled bushings to minimize rolling friction in the forward direction. This gave the mobility platform the stability it needed, as well as an increase in speed and controllability. Future work on this project includes streamlined integration with the sensor, the addition of a directional control method, and eventual marketing of the sensor assembly towards commercial water and natural gas pipelines.